Welcome to the TETRAS Workflow demo. If you've been following us over the past few months, you've seen a big push to get the word out about Tetris. As a small team, one of the best ways we can bring it to life is by showing you the system in action. As engineers, we're always looking for ways to improve. When we reviewed our YouTube content, we realized we hadn't done a great job of putting you in the shoes of someone who actually operates Tetris. That's exactly what this video is about. We're not going to break down every moving part of Tetris here, as we covered that in other videos. The goal today is pretty simple. Show how quickly a protocol can be added and executed on the Tetris platform. As a quick disclaimer, we don't synthesize in-house, so all the chemicals in this demo are actually IPA. The amino acid and reagent names you'll see are just placeholders to demonstrate how Tetris UI works. We'll also be using random volumes and shorter reaction and mix times than you'd see in a real run. The idea is to bridge the gap between a written protocol and the engineering operations that make it happen. For this run, we're going to be doing a simple synthesis. 2 tetrapeptides using the same amino acids but in different sequences. We'll use 2 different reactor vessels for this synthesis. The small 6 milliliter vessel, which can be seen here for AC/DC, and the medium 40 milliliter well, which can be seen here for AD/CD. If you're new here, please check out our snapshot videos on the different Tetris components for more details. For now, we wanted to give you a high-level look at the different components that will be incorporated during this demo. We'll start first with the injection stations. Tetris has 2 types. Internally sourced injection stations, which source chemical from either a 500 milliliter or 250 milliliter bottle that are inside the unit, as well as external injection stations. These external injection stations source chemicals from outside the system, in whatever size you choose. We'll also be incorporating these purge stations here. The main function is to purge a reactor vessel with nitrogen, but because of the volo pumps that you can see here, they will also be able to inject a wash chemical into the reactor vessel itself. In this case, we'll be using DMF. For this demo, we're running a refurbished Tetris T8 with the Volo system. This unit is about to ship to a new user and we're filming during its QA and testing phase. This T8 configuration includes 28 injection stations, with 20 of those being internally sourced and 8 being sourced externally outside of Tetris, 8 purge stations with corresponding Volo pumps for the wash chemical injection. These Volo pumps can be found in the enclosure here, so you won't be able to see it in this demo protocol. Here's our station setup for this demo. Our external stations, which you can see here, will be used for HBTU, dipea, aspartic acid, and 20% piperidine and DMF. These are common enough that most of our users will source these externally. Our purge station, 33, which you can see here, will be used for DMF as well as purging at the end of the synthesis, and stations 31 and 32 will be sourced internally, and they will be using alanine and cysteine. With the layout and protocol in mind, let's move on to Tetris UI, pop the hood, and give you a quick tour of the software.
Hello, I'm Joseph Goatley. I am Tetris project engineer. I've been here for roughly 12 years working on the Tetris. So to start off, what you will do is you will create your text file. So I am just going to use text. So I am going to call this SYS for synthesis. Next, we are going to type in our chemicals or the string of chemicals. So we are using the AC/DC. Now note you can use a custom abbreviation, but for this we're just going to use a 1-letter abbreviation. So next we'll be hitting enter in order to start a new reaction location. So this one will be ADCD. And now we will hit save. So save the file and then we'll close the file. Next, we'll bring up Tetris UI. In Tetris UI, you will then go to Libraries, Process Manager, to Libraries, and Import Sequence. Next, we will select the file. So you'll need to navigate to the file location. Mine was on the desktop under Synthesis. Most likely you will go as Synthesis Select, and then because we are using a single letter abbreviation, we do not need a delimiter. So you will then parse the file. So as you can see, here's the chemicals that we're using. On the next, we'll go to select our protocol. because we are using a small well and medium well, or 6 milliliter well and 40 milliliter well, we'll be using a small to start off all the coupling and protocols at first. This is just so that if I forget to change them, it doesn't overflow the reaction vessel. Next, we're going to go ahead and keep this skip initial termination. That'll be part of the process of the resin. To call this, I'm just going to do AC DC, just for simplicity's sake. Due to the size, because we are using a 40 milliliter well, I want to make sure my spacing is triple. And then I will generate. And then I will close this. And then as you can see now, it has popped up on my available processes. Next, I will go to libraries. Next, I will ensure that I have full access to this synthesis. So I will now go to Process Manager and click on ACDC. I want the first well to be the smaller one and the second one to be the larger one. So I will right click on here and go to Peptide Wizard. As you can see, it already has the steps generated previously, but it is using these protocols. So I will now increase the protocols to the second size, which I just have a second size already for the appropriate 40 milliliter well. Next, because I can customize each of the protocol steps, I will go to Next and choose one for each of these. I will choose single, single, and then just because if you want it, you can have a double and a double. So then I will go Next. I will select Continue. And it has now wanted to ask about saving, so I will now save. Close program without errors. Then I will move this over, and as you can see, it has now updated all these steps. The next part will be doing the enabling wells. We are now back to the point where we are going to be loading the wells. So first you will pick the wells. So we have the process, so the AC/DC process. So then we can click on the well location. We will then right click and you can either enable the well or you can enable the group. We are going to go ahead and enable the group so that it does both of them. Now that it has enabled the two wells, you can see there's enough room for each location on the carousel. If you accidentally loaded a well you didn't mean to, you can disable that well or disable that group. You can also, instead of enabling groups, you can enable individual wells. Now that we have the wells enabled, you will make sure that you're communicating with the Tetris, and then you will click Home. So when homing, the carousel will rotate back and forth and will eventually reach its home position, which lines up with the encoder and may not be visually lined up with the wells and station. But it is green when it has homed. Next up, we are going to click on the well location we desire first, right click, and bring to front. And them enabled, we will have to put the resin inside the wells.
Here you can see Joe placing our imaginary resin inside the reactor vessel. It pours right in through the inlet port on the top. We have these cleavage and vial racks for your convenience to use with the drain sticks, which you can see being slid right here. They can then be placed on the cleavage and vial racks, as you can see in the video, for ease of use and for cleavage after the synthesis is completed. As mentioned before, we'll be using a small 6 milliliter vessel for AC/DC and a large 40 milliliter vessel for AD/CD.
Software, right click, bring to front. When you click bring to front, it will move the carousel and the location underneath station 5, which is the front of the Tetris. Well then, because the small well is the first well, insert the small well into this location. Now that we have completed and put the small well in, we can then press OK because we are now loaded. We will then repeat with the other well.
With the software programming now complete, we'll head down to the lab to cover the different injection station configurations and the assignments for this particular demo.
We're now going to be looking at the internals. So we're using 31 for alanine and 32 for cysteine. So these have the bottle supply on top of them. So on the top of the bottle slide, you have a nitrogen tubing. So this will go to the nitrogen ring, which the nitrogen ring is what will supply the nitrogen to the top of the bottle. The purpose of that is to keep a nitrogen level over top of each of these chemicals. So next, we can remove this. So as you can see, it will go into the bottle on the left side and the fluid supply will come out on my right side. So to open and change these bottles, you will simply just remove them. And as you'll notice, this has a specific dimension for that size. If you are going to have a different size, it will require just slightly pulling up this tubing to make it match the bottle that you're using. And swapping out the bottles is just as simple as rotating and you're done. So next we're going to go ahead and look at the externals. For the externals, we're going to use 3 for HBTU, 7 for DiPEA, 34 for aspartic, and 35 for piperidine, 20% in DMF. So the external stations usually are the stations right next to the purge station, or depending on your configuration. They will be sourced from the side panel out into your supply. For our demo, we are just using IPA, so we have all of them coming from one. Normally you would have them separated into your different types of containers. So because this is a Volo Tetras, as you can see, this one is a T8, so it has 8 different Volo pumps. These pumps supply fluid to the back of the purge station. For this demo, we are going to be mainly focusing on using purge station 33 for DMF.
Now with the chemicals loaded, we can pair the chemicals with the appropriate injection station in the TETRAS software. To assign a specific chemical, you will right-click the station number and select Station Properties, and then select the appropriate chemical. You can then adjust the specific volumes for this synthesis and these chemicals from the main station dashboard. From there, we can move on to the clean protocol. The software walks you through each step to prime the system, starting first with the carousel homing. Step 2 ensures the carousel and the software are calibrated, and this is validated by the end user. This is done by specifying which injection stations will be used for the synthesis. We'll start by priming the externals first and then the internals. We'll then wrap it up by priming the Volo pumps, which will operate out of the purge station. Once we have all of this complete, we can start with the synthesis and let TETRAS begin operations. Now, TETRAS takes the ball and does what it does best. The intuitive software optimizes carousel movement for maximum efficiency throughout the programmed synthesis. In this quick montage, you'll see each component working seamlessly in tandem. Every station and vessel can run its own unique protocol, giving you unlimited versatility. Up to 108 separate peptides synthesized asynchronously. And the best part? There's no need to wait for a previous run to finish before starting the next. Now, all of this sounds great in theory, but you're watching a pre-recorded demo with a pre-scripted protocol from our team. Everything's going to go right. Where TETRAS truly stands out is when things don't go as planned. So, let's put that to the test. We're going to crash TETRAS and show how its modular design takes versatility to the next level for our users.
Alright, as you can see, the well location is aired out, and then when we go down the list, we can see the problem is that this station is aired out and there's no more 20% pipirpidine in the list of chemicals. Because of that, in this situation, depending on the problem, we would do different things. But for this one, we are going to remove it and put a new station on. So first, obviously make sure that the Tetras is paused so that it will not move while you're working on it. We have our spare station right here. The bottle's already on it, just so that the tubing's in all contained. So what you do is you reach in here, unplug it from the comm ring, unscrew it from the nitrogen, and then you would remove the station. So the station is removed. Obviously you have to be careful for the bottle because it still has fluid in it. Next we're going to take our replacement and we're going to put the replacement in its place. Screw the nitrogen back to the top. Then we will remove the bottle and put the original bottle back on. Now, in order to make sure that this doesn't get everything everywhere, we will put the other bottle back on this so that it is safe and doesn't get all over the place. Now you may hit resume.
These small engineering details are what really sets Tetras apart. With all this covered, we're now going to move on to finally queuing up another synthesis and completing the one that we had started.
So currently we are looking at this synthesis starting to finish up. So as you can see, it is still continuing through its process. But in order to be ready for the next one, we are going to go ahead and start setting it up. So just like before, you'll grab your notepad and you will create your peptide. So this is AGYS and AGSY. Save. And then we'll close this. And then while this is going, we can still go to the import sequence over and then select the file demo. And then we will parse the file. Now you can see this, and we'll continue. As you can see, the synthesis is right here, and if need be, I can go into the process, slide this over, and edit it as I need. So I can, just like before, go to the Peptide wizard to edit all these, or I can leave them as is. For this example, I'm just going to leave them as is so that we don't double what we did. After that, we have decided to leave this as is, we will go ahead and close this. It will give you a pop-up, and we do not want to reload and abort. So we're going to say no, so that this will continue to do its process. If you do abort, then you'll have to do a load process, but it's best not to. So next step is to wait until these complete, then remove the wells off the machine.
Now that we have completed the process, as I had said in the video, you will click abort in order to stop it, because until then it is just going to do a mixing. So now that we have stopped it, it is a lot easier to click release carousel in order to allow you to move these to the front. Luckily, the ones we are requiring ended up right here. So we know this is number 1, so we can remove it and place it in the 1 section. Then the next one, which is well number 2, will go into here. And now we have all the wells that we pulled off this.
All right, now that this process has completed, you may now remove these, because the way this is set up, you still have to abort it because it is finished. You click abort, and now you are going to stop all processes because you have completed it. Then you will go to your next process, and you can enable these wells.
Thanks for joining us for this long-form TETRAS Workflow demo. With Tetras, you don't have to wait for one synthesis to finish before starting the next. You can keep your workflow moving without interruption. If you'd like to see the full power of Tetras in action, book a live demo with our team today. Thanks for tuning in, and we'll see you next time.